Our next speaker is a successful PhD, economics PhD dropout. One of his favorite hobbies is convincing other people not to get a PhD. So if you're thinking about getting one, please go up to him at the Posit booth and say, hey, I'm thinking about getting a PhD, and let him have a chat with you. Everyone, please welcome Alex.
Seriously, I will do my best to convince you. So if you're thinking about it, just talk to me. I'm here again this year to try and convince you to care about boring operational stuff. So I'm going to spend the next 20 minutes to teach you to learn to love logging. If you want this presentation, it's not that interesting a presentation, but if you want it, it's on my website, alexkgold.space. So you can find it there. Just a little about me. I lead the solutions engineering team at Posit, formerly RStudio. And what my team does is we help our customers get sort of installed, up and running, deployed, configured with Posit's Pro products. And so part of that often is helping those people think about how do they take an app that they've developed locally, that they developed on their desktop, and get it out and share it. How do they get things into production? And so one of the things that we think about is this person, particularly like being on the other end of the phone from this person who's yelling at you because like the Shiny app is down, or like they're looking at your plots and the numbers are wrong, or the dashboard isn't working for me. I hit the slider and everything crashed. And like I think we've probably mostly all been in that moment, and that sort of moment of horror. And the reality is that like this kind of failure is sort of inevitable, right? You want to have good practices around testing your code, around version control, around controlling what goes into it, good pipelines, and that sort of thing. But this kind of thing is going to happen, right? And so the point of logging, which is again what I'm going to try and convince you to care about, is that logging is not really about avoiding failure, although it can help while you're developing an app. What it's really about is it's about letting you figure out what happened after a failure. Right? It's about sort of forensic analysis of being able to go back and be like, oh, I understand why this happens. So like when the dude is yelling at you on the phone, you can be like, no, I don't know what's wrong, but I know I can figure it out. That's really what the important thing is in that moment. So a little bit about logging, particularly for data science. If you were not at a data science conference, we were at like a JavaScript conference, that's right, like a web dev conference, and we were talking about logging, right? We'd mostly be talking about operational characteristics. We'd be talking about things like, does the button do what we want the button to do? Do results return in a sort of reasonable amount of time? Does the app crash when you try and use it, right? That's what sort of normal logging is about. As a data scientist, you have to care about that. We'll get to that in a minute. But you actually have another level that you have to care about, which is correctness, right? You have to care, are the numbers that are showing up correct? And fundamentally, because so much of data science is about discovering new things and learning things and going into uncharted territory, like you're not going to have something to check your correctness against. There isn't a given answer that you can just check, oh yeah, I got the right answer. And so much of logging for correctness purposes really means doing process checks, right? Does the process work the way I think it does? And so I'm going to introduce a spicy take here, which is that you should always use literate programming. Always. Full stop. See a little donut up there. Give me a fist. I love it. Right? Always use literate programming. So what is literate programming? Literate programming is a term coined by Donald Knuth. He's a very, very famous computer scientist, won the Turing Prize, which is like the Nobel Prize of computer science. So like this is not just me saying this. And he coined this term called literate programming, which is interspersing code, prose, and output in one thing, right? And of course, like we are here at an R conference, so you all are going like, of course I know. We're talking about like R Markdown. We're talking about Quarto. We're talking about Jupyter, right? And so this is sort of my encouragement is that like this is the way, right? We should not be writing R scripts and doing things we care about in them, because once you've done them, poof, it's gone forever. Right? You get no evidence of what just happened. If you do it in a literate programming format, right? If you're running just a job and you run it in a literate programming format, you do a smart thing of like printing some useful things into the console, and it gets messed up later, you can reconstruct what happened, and that's really useful. So like, you know, the way a project might look if you're doing this, right, is like you have your directory with your project, you have the like document you actually care about as a Quarto or an R Markdown, that's fine, not .r. And then you have your functions documented with Roxygen, just like if you were doing it for a targets pipeline, and you have your test that you know, stuff as well that you should throw in there. So that's sort of big picture, right? Just do the job in a literate programming format, because then you get to keep the output, and you can also put some, you know, comments about like, oh, this should look like this, and if it doesn't, that's a good hint. A couple thoughts on what you should log into those literate programming formats. One thing I'll recommend is the point blank package. If you've never used it before, it's a really cool package. Helps you create sort of a data validation workflow. I'm not going to spend a lot of time, but it's like really cool. Strong recommend. You can have it. There's a lot of automated stuff it can do to validate that your data is what you think it is, and you can also sort of build your own validators quite easily. It's a very cool package, and can work in a lot of different kind of pipeline mechanisms. There are two things in particular I'm going to encourage you to log into that literate programming format, whatever you're using. The first is your joins, and I know this is really like have used Stata. Stata's joins are amazing because it gives you statistics on how many records joined and how many didn't, and how that works. And so, you know, but you can do this yourself, right? You can like do the math. If you go to join two data sets, you can look at how many unique IDs are in data set 1. You can look at how many unique IDs are in data set 2. And you should have an expectation before you do that join of exactly how many rows are going to be that, right? You should, it's not like, there's no magic there, right? You could say like, oh, there are this many unique IDs here. They match uniquely to this data set. We should have a one-to-one match. Or I know there aren't. There are going to be duplicates. I should have some sense of how many. So ideally, do the math and just figure out how many there should be. Now, that is a pain in the butt. I'm not gonna lie. So like, I usually don't do the math. But what you can at least do is you can document in your literate programming format, right? How many rows did I start out with in each data set, and how many rows did I end up with in the join data set? Because that gives you some really good information if you look back later, right? Very often you're expecting your joins to be unique, so you have, you know, 1,000 rows over here, 10,000 rows over here, and you're expecting 1,000, and you end up with 1,010. That's usually a really good hint that something weird has happened. So at least document how many rows are in the sort of resulting data set. And the other thing you can do is look for duplicate IDs, right? If you're expecting that data set should join uniquely, just check. Are there any duplicate IDs, right? These are really easy checks that if you throw into that script, all of a sudden you know, and you go back later and you go, oh, there were a bunch of duplicate IDs here and I expected none. That's a really powerful signal. The other thing that I always check as a matter of course is recodes. And what I mean by that is like when you have, you know, a certain number of categorical variables and you're, you know, taking months and making them quarters, when you're taking the entire rainbow and making it, I don't know how you split up a rainbow, but like 3 chunks of a rainbow, right? Or numeric values and chunking them, right? The simplest thing you do is just cross tab your values before and after, right? And do they look the way you think they should look? It's again, very simple thing to check, but I can't tell you how many times this has saved my butt to just dump this into my Quarto document. And also, especially any that don't recode at all, right? That's a really good signal, especially if you're running a job over time, right? You get new data in and like somebody's going to secretly add a new value that you don't expect to that variable. Being able to catch that is really important and can really sort of you know, save the day later on, or at least help you reconstruct what happened. One other category that I honestly don't have a lot to say about, but you should pay attention to is machine learning models. If you've got a machine learning model, you're running it on new data, you got to check for model drift and quality. There are a ton of proprietary frameworks to do this. If you want an open source framework, Vetiver is great. It is particularly great for sort of relatively small collections of experiments. If you're running hundreds or thousands of machine learning models in production, Vetiver, which is a sort of model ops RN Python package that lets you deploy, version, monitor machine learning models. It's great sort of if you're at a relatively modest scale, but if you're doing hundreds or thousands, you're going to have a proprietary solution to do this. Cool. So those are some thoughts on logging for like data science purposes. Now let's talk about like logging for logging's sake. And I mean this in terms of the operational qualities, right? Does the app run in a reasonable amount of time? Does it crash? Those sorts of things. And so what a lot of people do here is they just print, right? You just print stuff, right? That works. It's not bad. And so what I want to talk about is just that you can up your game to do better with like very little additional work. Like that's what I'm going to try and convince you. So there's a great package called log4r. It's inspired by a package called log4j.s, which is a big JavaScript logging package. It's maintained by my colleague Aaron Jacobs at Posit. And it's just a really elegant sort of logging framework that makes it super easy to add logging to a script that you otherwise might just dump print statements into. Now, there is a little bit of a mental model to have around logging. It's not hard, but when you're logging using a logging framework, you don't just print a statement. Instead, what you do is you give a logging level, right? And so logging comes, these are the ones that log4r uses. Different packages have different levels, right? There are 5 levels, and they sort of go up, down. That's hard to say. In terms of level of severity, right? So they go from debug to fatal, right? And so debug is the kind of thing that like just you care about. It's like, oh, right, did the thing run correctly, right? It's like function internals you're going to log as debug statements, all the way up to fatal, right? Like app is crashing. Here are my parting messages to the world. Goodbye, cruel world. Like that's fatal, right? And so what you can do is you can in your code, and I'll show you this in just a sec, you declare this statement that I'm making is this level of severity. And then when you're running your code, right, you can provide, usually in an environment variable, what level do I want this time to log at? So when you're developing locally, you could run it all the way on debug mode. So every little bit of documentation prints into your console. And then when you're running it in production, you probably want to choose something a little more severe so that not every little bit of information gets dumped into your console. So actually, I'm going to stick with, yeah. Okay, so I'm going to talk about a little bit of code here. Does this have a, no. I don't know what that button does. I thought maybe it was a laser pointer, but it's not. There is one on here. Is it this? It's that. Great. Okay, we've got a laser pointer. Okay, so this is some code that it's a Shiny app that includes some logging. And so it's really easy to add this logging code to your app, right? The main thing you need to add relative to just some print statements is up at the top. You've got this little, can people see the laser pointer? Is that visible? Sweet. Okay. You've got this little like, I am instantiating a log. Great. I've instantiated a log. That's going to remain throughout my session. It's going to print stuff out. And then I just have these log statements. So for log4r, it does this with the function names, right? You could think of it, right? Like you could alternatively design this package to have taken arguments, but these are actually the function names. So you have log4r info, you provide the log object, and then this is just like, what is going into the log? I have another info. What's going into the log? Here I have a try catch block, and if an error happens, I dump a lot of stuff into the log, right? And that's generally a good practice because again, a huge point of the logging here is forensics, right? Is later on we want to be able to come back and forensically examine what might have happened that was bad. So I'm going to show you this. Looks like the Wi-Fi is not being my friend, so I'm going to just do it live. Here we go. Can we see my RStudio? Yes, we can. Okay. So let's run this app. Actually, I'm going to clear off my console here. Run this app. Okay, this is a little Shiny app. This is taking the Palmer Penguins data set, which is just a data set of like information about penguins. And it's letting me, it has some selectors here, right? I can select a minimum bill length, I can select sex and species, and it computes just the average mass of the penguins in that little subset of the data. And you can see down here, right? I got my app started, told me that, and it told me that I hit the compute button because I set it to do that. So, oh, computation requested. Cool. Now, when let's say I do something that I intentionally designed this to crash, but like, crashed my app, right? And what you can see is that then that try catch block got invoked, and I get all of this stuff dumped out, right? And I get dumped out here. It's a little bigger. The values that I input here that yielded a bad outcome, right? And I could do some digging, like why did this cause a bad outcome? It turns out there are no penguins with a bill length of 60 or more. So this is trying to compute an average on a set of size 0, which doesn't work, right? So this this now, I have the information now to know, well, I got not a number error, right? That's a big hint. And then I can actually like go in and forensic my way around these actual values, which can be a really helpful way to be able to do this. The other thing I'll point out, right, is that relative to just printing print statements, where you have to, with a print statement, you've got to like get in there. Every single little bit of information has to go into the actual print statement, right? That's different here because the log, this is all auto appended by the log, right? It's giving me the info. It's telling me that this is an info, and it's giving me a timestamp here, and you can add other things. When you invoked the logger at the top, right? This invoking the logger, you can add more stuff, right? You can give it a custom format that prints a ton of information in there, including like session information, user information, all kinds of great stuff that then you get for free in each line of the log. And I'm going to switch back to my presentation. There we go. We're going to close RStudio. Yes. Don't save. Never save your workspace image. Never save your workspace image. Okay, other things that you can do that are useful is what you saw there is it was logging to the console, right? It was just going to my R console. That's useful because then I can print it out. If you're on Posit Connect, it just goes right into the logs that you get there on Connect, which is nice. But there are other places you might want to log. For example, you might want to go to the syslog. This is very common when you're using Docker. That a lot of Dockerized deployments are you set up logging so that it's the syslog that sort of gets sucked out of the container. Or if your organization has a logging framework that they use, a log aggregator, something like Splunk or Datadog or some of these things, very often you're going to ship those logs right off to an HTTP location. There is also a file appender, so you can also put things in a file. Many logging systems just like watch a file. The other option here is to do structured logging. Again, if you're shipping it off to another system, oh, excuse me. That's a nice way to be able to do it. Usually that would be a JSON blob, and you just sort of put the log in there, and then you have other systems that would consume that JSON blob and do something with it. Cool. So that's what I have to say about logging. So as a data scientist, you unfortunately have to care about two kinds of logging. I am sorry. You have to care about operational logging. I recommend using log for R. You got a very brief tour through using it. As you can tell, that did not take very long. It's like very simple to use. It's barely more complicated than print statements, but it gives you a much richer set of information, a much richer configuration to be able to use. And then you have to check for correctness, which of course is the task of literate programming. I will, if you thought this was even moderately interesting, I'll take moderately. This is a book that I'm working on called DevOps for Data Science. It is available at do4ds.com. The manuscript will be final up here like this week or next week, which I'm so excited. Thank you. Yes, I'm so pumped. There will be print copies at some point, but it will be available online forever. So if you're interested, the first whole section of this book is about things. This is chapter 4, logging up there, right? There's a lot of stuff in here that's sort of advice for data scientists to make your apps and projects more sort of like welcoming from a DevOps perspective, make them work more smoothly. Things like logging, also stuff around CI/CD, deployments, package management, all that kind of like stuff that I love and people think is boring, but they're wrong. Super cool. Then the rest of the book is really about sort of IT stuff. So there's some stuff about how to set up servers, how to use Docker, and then some stuff at the end on why, if you work at a big organization, they probably aren't going to be very happy with you doing this yourself, and how you can maybe work with enterprise IT admin folks to make this work better. Since I'm here at the Lander conference, I want to give a special shout out to Gus Lipkin, who is a Lander employee and was one of the first readers of this book and gave me a bunch of really useful feedback. So thank you, Gus. It's up there in the back. It's way better than when he read it. So it was bad then. Anyway, thanks for tuning in, and yeah, go log some stuff. Thanks, everybody.